Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahmi Iskandar bin Bazli, and today we are going to present you about Turbo Code. Okay, first of all, the history about Turbo Code. Turbo Code is one of concatenated coding scheme. Okay, concatenated coding scheme were first suggested by Forney, the founder, to achieve significant coding gains by COM2 or more relatively simple component or block code builder. The result of codes had an error correction capability of much longer code and were endowed with a structure that allow relatively simply to moderately complex decoding. Okay, serial code concatenation is most commonly used for power limited devices such as deep space probe. The most famous of these schemes is the Reed-Solomon outer code. Apply first, remove last, followed by a convolutionary inner code, which is apply last, delete first. So this turbo code can be thought of as a refining of the concatenated encoding structure and a iterative algorithm for decoding the corresponding code sequence. Okay, for this turbo code were introduced by Barrow, Glavitt, and Matsushima for a bit error probability and code rate 112. This outer report require E, B, stroke and node of 0.7 dB. Okay, codes are constructed by applying two or more component code to various interleaved versions of the same sequence of information. Codes are constructed for any single conventional code. The final stage of the decoder yield hard decision decoded bits or more generally decoded symbol. In order for the concatenated scheme such as turbo code to operate properly, the decoding algorithm should not be limited to making hard decision between the decoder. In order to make the most of information learned from each decoder algorithm must have an effect on the sharing of soft rather than hard decision. In the case of device with two component code, the idea behind the turbo decoding is to pass soft decision from the output of one decoder to the input of the other, and to iterate the process many times to make better decisions. In turbo code, many concepts can go through: likelihood function, the two signal clusters, log likelihood ratio, principle of iterative decoding, log likelihood algebra, extrinsic likelihood, and encoding with recursive systematic code. Okay, turbo code performance in terms of bit error probability has been shown to be very close to the Shannon limit. In this report, the mathematical measure of a postulate probability and likelihood are reviewed, and benefit of turbo code are discussed. From this report too, we provide a numerical illustration using a simple concatenated coding scheme. It offers a vehicle to demonstrate how error performance can be enhanced when soft output from the decoder are used in the iterator decoder phase. So close to us, turbo code are used in 3G and 4G mobile communication, example UMTS and LTE, and in satellite communication, as well as other applications where designers seek to achieve reliable information transfer over bandwidth or latency constrained communication links. Okay, there are two examples involved in about turbo code for communication engineering application, having additive with wide Gaussian noise and likelihood ratio. Okay, that's all.
Okay, for the methodology part, this turbo code concept can be separated into three types that are likelihood function, the two-signal class case, the log likelihood ratio, and the principle of iterative turbo decoding. Okay, for likelihood function, on Bayes' theorem, the mathematical foundation of hypothesis testing rests. The most useful form of Bayes' theorem expresses the a posteriori probability that is APP of a relation in terms of a continuous valued random variable x in the following form for communication engineering, where applications involving an AWGN channel are of great interest. And this is the sample of the formula that can be used or equation that can be applied. For the two-signal class case, let the binary logical elements 1 and 0 be represented by voltage positive 1 and negative 1 respectively electronically. Whether it appears as a voltage or as a logical element, variable D is used to represent the transmitted bit of data. Sometimes one format is more convenient than the other. The difference from the context should be recognizable by the reader. Let binary 0 or the voltage value negative 1 be the added null element. For transmission of the signal over an AWGN channel, the conditional PDF referred to as probability function are shown in figure 1. The function on the right shows the PDF of the random variable x condition on the transmission of D equal to positive 1. The leftmost function shows a familiar PDF conditional on the transmission of D equal to negative 1. For likelihood ratio, it is a real number representing a subdivision out of a detector, designated by as follows. This is the sample of the equation, where LXD is the LLR of the test statistic X obtained from measurement of the test statistic X under the alternate condition that D equal to positive 1 or D equal to negative 1 may have been transmitted. Channel output X and LD is the priori data bit of the LLR. For principle of iterative turbo recording, a demodulator is often designed to produce soft decisions in a typical communication receiver, which are then transferred to a decoder. Compared to a hard decision, the error performance improvement of system using such soft decision is typically approximated to a 2 dB in AWGN. Such a decoder could be called a soft input or hard output decoder because the final decoding process out of the decoder must terminate in bits hard decision. A hard output decoder could not be appropriate with turbo codes, where two or more component codes are used and decoding involves feeding output from one decoder to the inputs of other decoder in an iterative way. This is because difficult decision on a decoder degrades system performance compared to soft decision. A soft input or soft output decoder is thus necessary for the decoding of turbo codes.
There's 4 of subtopic for my part. Okay, for the first one, component code for implementation of turbo code. The main principle in the turbo coding scheme is to use two codes in parallel. This means that the information sequence is encoded twice, the second time after reordering of the information bits. The component codes are chosen as small convolutional codes in the recursive systematic form. With this encoding, we are able to decode the two encoded streams with an interactive process using two soft-in, soft-out decoders, one corresponding to each of them codes. As you can see the derivation, the log likelihood ratio can be divided into the log likelihood ratio for the priori probabilities and a component depending on the parity bits and a priori probabilities for the surrounding information bits. The output from the first decoding in decoder 1 can be used directly as a priori probabilities in decoder 2, but when we return to decoder 1 for the second iteration, we cannot use the output from decoder 2 directly since part of it come from decoder 1 in the first place. This is mainly we therefore subtract a priori before the results are used in encoder 1. However, there is still some positive feedback since this depends on the priori probability for the surrounding information bits. This means that we cannot ensure that the interactive decoding algorithm will converge. For the second part, concatenation of RSC code. Consider the parallel concatenation of two RSC encoders of the type as shown. Good turbo code have been constructed with the component code having quite short constraint lengths. An example of such a turbo encoder is shown where the switch yielding VK punctures the code, making it read half. Without the switch, the code would be read 1/3. Additional concatenation can be continued with multiple component codes. In general, the component encoder need to be identical with regard to constraint length and rate. In designing turbo code, the goal is to choose the best component code by maximizing the effective free distance of the code. At large value of EB per NO, this is tantamount to maximizing the minimum weight code word. However, at low value of region of greatest interest, optimizing the weight distribution of the code word is more important than maximizing the minimum weight. For the third part, feedback decoder. The Viterbi algorithm VA is an optimal decoding method for minimizing the probability of sequence error. Unfortunately, the VA is not able to yield the APP or soft decision output for each decoded bit. A relevant algorithm for doing this has been proposed by Ball. The Ball algorithm was modified by Beru for use in decoding RSC codes. The APP of a decoded data bit can be derived from the joint probability defined by this. Thus, the APP for decoded data bit dk represent as a binary digit is equal to, for the last part, decoding with a feedback loop. Decoding with a feedback loop is to see how performance the turbo code. It is the extrinsic information supplied by the decoder and does not depend on the decoder input. Ideally, LLR's channel measurement and function of the redundant information are corrupted by uncorrelated noise, and thus the function of the redundant information may be used as a new observation by another decoder for an interactive process. The fundamental principle for feeding back information to another decoder is never feed the decoder with information that stems from itself, because the input and output corruption will be highly correlated.
Okay, as a conclusion from our group conclude that in the presence of data corrupting noise that occur during the process transfer, the turbo code mostly used in the mobile and also satellite communication, which is able to achieve bandwidth information transfer. In addition, as the soft output from the concatenated decoder, which is often used in the process, there is a numerical example to define the performance of the turbo code was improved. In addition, the turbo code also involved of the partial analysis and patching of the interlayer component codes. The turbo codes actually approve closely the performance limit, which is promising the interactive decoding and decoding concept, which is considerable as a saving of by several order of magnitude compared to the single code. Therefore, turbo code principle or turbo code concept, known as a new error correcting solution, which is the process of the data interactive in the receiver so that there's no information was wasted, and therefore it can help opening a new way thinking or in the construction of the communication algorithm. Okay, that's all.